Welcome, colleagues, to another summer rerun of We Want to Believe. Today we are listening to our episode 50 special, Mars, with special guest Dr. Matt Siegler, and we get to talk to him about all things Mars, from the best type of fake dirt to different Mars rovers, and space cocktails, and lots of other stuff. It's really interesting. We learn a lot, have a lot of fun, so enjoy the episode. Bye, but not bye. Here it is.
I'm Helen.
And I'm Liz.
And we're sisters,
Scientists.
and lifelong X-Files fans.
And this is We Want to Believe.
All right, welcome back, everybody. We have a special episode for you today.
Yeah, welcome to our 50th episode of our podcast. And to celebrate, we are doing a special Mars-based episode. We are interviewing Matt Siegler. And Matt, it occurs to me, I'll be honest with you, in my head, I'm like, oh, yes, Matt Siegler, Mars. I don't remember exactly what it is you do. I just know Mars. That's the Mars man I know. I've been like, oh, let me email that Mars man. So maybe you could tell us a little about yourself and remind me exactly what you do with Mars.
Okay, I am a planetary scientist. So I'm kind of in transition right now between working for the Planetary Science Institute and starting a new position at University of Hawaii. So that's an exciting new thing in my life.
Yeah.
And basically what a planetary scientist does is looks at all the data, usually not from telescopes and stuff, but from the spacecraft we send to the moon or Mars or Jupiter or whatever. And so I kind of characterize my work as working on anything involving temperatures. So I work with a lot of infrared cameras that are on different spacecraft, a lot of microwave instruments, which measure temperatures kind of below the surface. And so sometimes these things go to Jupiter's moons, sometimes they go to the moon, sometimes they go to Mars. And so for Mars right now, I'm working on I was a member of the InSight Mars mission, which was sticking a thermometer in the ground to try to measure the thermal heat flow. Fortunately, we didn't get as deep as we hoped, but hey, science is hard. And then I'm also a member of the Mars 2020 or Perseverance rover team, where we are trying to use the radar that's on the butt of the rover to measure the temperatures underground as well. And then it has infrared instrument on it too. So
awesome.
How deep did you get? You said it didn't go as deep as you'd wanted.
Yeah, so the probe from InSight was designed to go about 5 meters deep, and unfortunately it got about 30, 40 centimeters deep.
So
we kind of lived and learned, but Mars basically threw a curveball at us with essentially we expected the soil to be more like sugar, where it would fall in around the probe. So the probe kind of acted, it's called the HP3 or heat flow and physical properties probe that was on InSight, and was basically a jackhammer. But normally when you have a jackhammer, there's someone holding it and pushing it down.
Right.
And so on Mars, we were expecting the dirt to fall into the hole and kind of squeeze the probe into place, and then it would be able to hammer against that. But essentially, rather than being like sugar, the soil on Mars was more like brown sugar, where it packs a little bit. And so it basically created a hole, and then the hole didn't fall in around the body of it, and so it ended up kind of just bouncing in place, and then packed its path tighter and tighter before it could get through it.
Man.
And the engineers tried for nearly a year to try to get it to work, but sometimes it's hard to get something to work from 100 million miles away.
Wow.
Weird timing. I got an email from my department chair yesterday, not just to me, but like to, I don't know, several departments, that was like, oh, we've just got this question, like if we'd be interested in applying to get, like, does anybody want some simulated Mars soil?
Oh yeah.
And
Oh,
yeah,
Yeah, we play
did
with
you
that
say
stuff all
yes?
the time. Yeah.
yeah, what I said was on a personal level, yes. And then but like I'm like it sounds like it's like several gallon buckets that you could get. And I'm like, I don't need gallons and I wouldn't have anything to do with this for my classes. But look, if some ends up here, yes, please. And she said a lot of people had similar emails, so they might just get some and just share it. So you've played with it?
Well, sure. And it's basically there's a fake Mars dirt for every purpose, right? So, and there's like huge debates about this, about which Mars dirt are you using? Oh, that's the wrong one for that. And so
That's so awesome.
yeah, so basically it started was they had the spectra from, from different instruments that had gone to Mars in the past, from Viking, I think was maybe where they first got it from. And they found some rock in, I think it was on the slopes of Mauna Kea in Hawaii, and said like, hey, if we crush this up, it will have pretty much the same spectra as the dust we saw on Mars. And that worked pretty well. And then people were like, oh, well, I'll try to grow plants in it. And we're like, whoa, whoa, whoa. Like it matches the spectra, but it doesn't match the shape of the grains or how it would drain water away or how, and then what I work on a lot is how heat will flow through the grains.
Oh, okay.
And so for that, it depends a lot more on the shape of the sand rather than the actual chemical composition. And so then you needed to, oh, how does Mars make sand? And like you think about
Oh,
it on the moon, like it's covered with dust, right? But it's made a lot differently than the dust on Earth. The dust on Earth comes from wind and from water erosion and all this. Dust on the moon
right.
is from like little meteorites falling from the sky and smashing into.
Oh,
And so Mars is kind of somewhere in between, where it's a mix of like windblown dust and and basically, yeah. And so that gives a lot of the dust grains on Mars these really like platey shapes, that you know adhere together really well. And again, that was the problem with the
Ah,
the dust didn't fall the way we expected. Was it was a mixture of more platey dust and less round dust than we expected. And
wow.
yeah, and so yeah, there's a lot of different kinds of fake dirt.
that's awesome. That
Would
is,
you
I
be
feel like is like a great
Yeah, and there's a
pull
fake
quote.
dirt for the moon, there's fake dirt for Mars, there's if you want to try to
Oh,
simulate ice
that's
on
awesome.
different planets, people try to make simulants. And yeah, there's a couple different of these factories essentially that make different kinds of fake soils to you know pretend what it might be on other planets and how your measurements are going to look.
God,
wow?
that's cool. Were you gonna say something, Helen?
Yeah, I was going to ask, could you give us kind of like a Mars crib sheet? What do you need to know?
Yeah,
What are
what do you
the
need? What do you need to know? I like that. Like
What
the
do you mean?
what does the average person need to know about Mars? Is it a threat? No. But
It's
like,
coming for you.
yeah, yeah. So like, I have. I mean, well, actually, pause for a sec.
Sure.
Here's something that occurred to me this morning because I was going to say, oh, like I have a physics background, but then I'm like, I don't remember how I know you. How do we know each other? Because
Okay.
you were an intern at
So
Fermilab, but it wasn't the same summer that I was an intern at Fermilab.
yeah,
So
I
how do I
was
know you?
pretty much every summer between 2000 and 2004, I was an intern, except for the summer that you were an intern.
Right.
So,
Okay. Yeah,
so
and I
I
was an
I
intern in
basically knew
'02.
all the interns for eternity. I think my good friend Jen Seiler was in your
Oh,
year. That's
Jen.
Oh,
Yes. Jen. Oh, because you went to Cornell, right?
yeah.
Okay,
Yeah,
because
and
and
that's
Jen
kind of
went to
how I got
Cornell.
into the Mars bug. I was originally at Ithaca College as a film major. And
Oh,
then I
that's
did
so
that
cool.
internship at Fermilab and was like, oh, maybe I want to do science. And I had been like working a little, like volunteering for the Mars rover group at Cornell, because that was the old Mars rover, Spirit and Opportunity, were led out of there.
Oh,
And
cool.
I kind of was like, oh, that's cool. And then basically the same day I started as an intern at Fermilab, I got my acceptance to transfer to
Oh,
Cornell.
that's
Like,
awesome.
okay, this seems like a cool new. And so I kind of then specialized in physics and astronomy, and got working on the Mars rovers during the school year, and then I still did a film major in the end. So
Oh,
when
That's
wow.
awesome. That's
so
awesome.
I had my double major in physics and film, and yeah, at the end of undergrad was like, okay, do I go and work in Hollywood, or do I like go to Switzerland to work on particle physics stuff, or
Man,
like do this
I
Mars?
feel like you should like at some point you'll become like a specialist for Hollywood people to be like, I need to make the best sci-fi or
Oh,
whatever. And it'll be like, we know the exact, there's one person who's perfect for this.
well, it was really cool. The so when I was a postdoc at JPL, I I got a call up to interview to be a script advisor for the Cosmos series.
Oh my God.
And
Wow.
and it was Brandon Braga who, some people might know as he's like did a lot of Star Trek: The Next Generation. He was
Oh, okay. Oh my
director for a
God.
lot of those, was the main director there. And so like I went in the office to interview him, and it was because Seth MacFarlane was funding it. It was the interview was in the Family Guy studios.
Oh my
Oh my
So that's where the Cosmos series started, was out of the Family Guy studios.
wow.
And so yeah, I got to go interview at the Family Guy studios, and Brandon Braga looked over my resume. He's like, "What? This guy has a double major in physics and film? Why are we even interviewing him? This is perfect." So yeah, it's come in handy a few times like that where I have the knowledge of the film world and the science background, and that I kept going, and got the PhD and everything. And so yeah, so it's fun, I'm primarily an active scientist, but anytime I can get involved with that kind of stuff, I do.
Yeah, that's awesome.
Yeah, we
And
did
I,
a YouTube series with Jorge Cham, who does the PhD comics, if you've ever seen those.
oh
Oh,
yeah, that's
So
awesome.
yeah, so you can
Yeah.
look at us at PhD
Yeah.
TV on YouTube.
HGTV. Okay.
that's
Yeah.
awesome.
Yeah. So I was just gonna say, like, before you give us like the things we need to know about Mars, I feel like, okay, so because I did astronomy stuff in grad school, I got my master's in physics at NIU at Northern Illinois University, and I did stuff with the redshift of galaxy clusters. So
Cool.
local stuff, I feel like I know. I'm like, I should know a lot more than I do. I have taught astronomy, but it's been a long time. I commute about an hour to my job, and so I am like, I don't ever. And now we hired somebody who's an expert in astronomy, but I'm like, I never wanted to teach it at my current job because I don't want to have to do nighttime labs, and so because I don't want to drive at night. So
Yeah, yeah.
I haven't taught astronomy since I don't know. It's been like 14 or 15 years.
Okay.
And so I definitely held that information in my head at the time I was teaching it. How
Yeah.
much is still there? I'm not sure. And I do have one specific question that a student asked me once in class that I want to ask you about, but I'll wait on that. And then I was also going to say, I don't know how much I told you about us in general. Helen's a professor. She's in her office, as you can see there, but she's what are you, biologist? I would never know exactly what to say you
I don't know
are.
what your own sister does.
But well, she has a lot of things. I'm gonna go with like, because you're in the biology department, but you're a
Yeah.
bioarchaeologist. Is
Yeah.
that
Yeah.
true? Yes.
Yes,
Okay.
that is true. Yeah. I'm an assistant professor in the biology department, but my research is in bioarchaeology.
Okay.
So yeah.
There we
So
go.
I know
We have in our
nothing
field,
about
we have
space.
astrobiology, which sometimes people call bioastrology by accident. So that's what bioarchaeology.
I did have the same student I once had on like day one of teaching an astronomy class. I had a student ask me when we went over the syllabus, when are we going to learn about like our zodiac signs? And I was like, well, it was awkward.
Yeah, that's where you always got to come in with, well, because of the precession of the equinoxes, the position of the zodiac signs, so the where the North Star is changes over a 13 or 26,000 year cycle. So every 2,000 years, you've gone a 13th of the way around that. And so that means you've changed about one zodiac sign every 2,000 years. And all the charts that people
Huh.
use for zodiacs are basically like handed over from the ancient Greeks or whatever. And so they still use
Ah,
the wrong sign. And the sign that
Ah,
is your zodiac sign is actually switched by a month off. I think you should be what you are actually is a month earlier now from the charts that you're looking at.
No
So don't
kidding.
base too
that's
much on your zodiac
awesome.
because you've been reading the wrong one your entire life.
There goes all of my zodiac-based decision making. No, that's wild. And see, yeah, that's I think the fact that I didn't have that sort of response is a consequence of the fact that like I was like, look, I know more than the students, but just a little. Like I know
Yeah.
just enough in advance, because the
That,
the local
that's the
stuff I don't
secret of
know.
being a good professor or to good teacher is
Yeah.
you just know
Just
a little
I
bit more
stayed.
than the
I mean,
student.
Yep.
I taught a physical science class without ever having taken physical science. So, I was like, I can read the book, I can understand it better than them, and then I can teach it. I don't know. That was not in my current job, so I don't feel too weird saying it. Um, but yeah, and then Helen also has gone on the record several times as saying she is in general afraid of space. Um,
Yes, I
yeah,
am.
so,
Yeah, it's
yeah.
it's too big. I mostly work with microbes. And
In
so
space.
I mean,
No.
that would be awesome. Yeah. But yeah, space is just a little too big for my comfort. I think it's fascinating, but I get kind of the willies occasionally thinking about just how large things are.
Yeah, I mean that's what sometimes people ask you as an astronomer. You're like, "Oh, do you ever want to go into space?" And I'm like, "Actually, I'm not sure I would." That I like already miss my kids enough on like a 2 day work trip.
Yeah.
Oh, I'm gonna go to Mars for 6 years. And just that change, but also I think, you know, you want someone who's going to follow directions working on the moon or on Mars, you know. I'm kind of personality would be like, "Ooh, look at that shiny rock," and run off, and and they're like, you realize that every minute you were on the moon, or it's costing us $3 million. So yeah, yeah, and I don't know.
How
There's
how
more the
long would it?
claustrophobia of being stuck in a spacecraft
Yeah.
than the
I
agoraphobia of like,
oh yeah.
I'm gonna fall out into it. But both ends are scary. Yeah.
Yeah, I'd lose my grip on reality like immediately, I think. Like I don't even do well if I have to stay up all night for like a red eye flight. I start
Yeah.
to feel a little crazy. So, yeah. So, Helen, sorry, you're going to say something? I think
Yeah. So
maybe.
how far away is Mars? How long would it take to get there? You said 6 years. Is that,
No. So
or was that just an
that
estimate?
was
I mean,
kind of
what's the?
a random.
Okay.
So
Okay.
basically, Mars goes around the sun in about a 2 year period, a little less than 2 years.
Okay.
Um, or maybe it's a little more than 2 years. That's a fact I have to double check.
I
But
mean, we get things wrong constantly and then have to correct it. So,
yeah, so but that
yeah.
means that every time Mars goes around the sun once, the Earth goes around twice. And so that means roughly every 2 years we get this alignment where Mars and the moon are Mars and and the Earth are fairly close. I think it's like 80 million miles, something of that
Oh my
sort.
gosh.
Mm.
That's fairly
Forces.
close.
Yeah, yeah. But um, then for the other, a year later, then you're on opposite sides of the sun from each other, so that's the 80 million plus our 100 million that we're away from the sun, plus another 100
That's
million.
another.
So yeah, so almost 300 million miles. So it really depends when you're asking how far Mars is away. And then that's basically why you'll see like a tradition of like, oh, the Spirit and Opportunity launched in 2003, and then there was another mission in 2005, and then there was another mission in 2007. And, so you look at the
Oh,
history, you see like we've tried to keep this cadence of roughly every 2 years. And
okay.
occasionally, like with the Mars rover, it got delayed. And so they basically had to wait another 2 years to get another opportunity. Because if you
Wow.
send it during that time when Mars is close, obviously it's going to take a lot shorter time. It takes, roughly between 6 and 10 months, depending on the year. Um,
Wow. That
and
still is a really long
yeah,
time.
at its closest. But then to wait, so that's the question with people then, right? Is you send someone when it takes 6 months to get there, right? When Mars is close.
You don't
but
want to do a
either you
weekend.
get them back right away, kind of do like we did with the moon, where you send someone, they spend a week there and then come back, or do they stay for at least 2 years before
Oh,
Oh my
coming,
wow.
God.
right? So that's kind of the next opportunity, because otherwise they're going to spend, an incredibly long time in transit between the Earth and Mars.
Right.
Yeah, and it's funny. This was actually Johannes Kepler worked all that out. Like,
That's awesome. No kidding.
yeah, of that you would get these close approaches to Mars, every 2 years or so.
Oh,
Yeah.
that's great. So the question that I got asked by the same student who asked me about the zodiac back when I taught astronomy 15 years ago, she asked me, and I brought it up on the podcast before, if I thought I would see people go to Mars in my lifetime. And I had nothing to base it on because, like I said, it's not my area of expertise, but I was like, I don't know. I feel like, yeah. I no longer am so sure, but at the time I felt like, yeah. And she said, women's intuition, which I thought was
I
hilarious.
mean, I'd say this is kind of how I based my career decisions. So like I said, I met you, we were interns at Fermilab, right? I
Yeah.
did particle physics. And so when I was applying to grad schools, I was like, okay, do I want to work on particle physics stuff, or do I want to work on, planetary astronomy like Mars stuff? And I said, it looks like they're going to find the Higgs boson when I'm in grad school. And that would be fun, and it'd be a neat thing to be involved with. But then, like, is the rest of
What's
my
next after
career like
that?
lobbying for the gigantic super collider that, is going to cost $500 billion and, may or may not happen in my career. Even if it gets funded in my career, would it, you know,
Be built or whatever.
um,
Yeah.
and and then otherwise it'd be like, okay, I'm going to measure the eighth decimal place of this tau.
Mass or whatever.
Yeah.
Yeah.
Yeah. So it felt like, okay, like it seems like we might send people to Mars in my career, and that would be a fun thing to be part of that
Yeah.
whole process. And so I kind of banked my career on that in some way, is that I really do miss working particle physics. Like, in particle physics, you get to touch the hardware, right? Like you go
Yeah.
in the lab and mess with it. Like when you're sending something to Mars, it's some special engineer that's going to build that thing, and you maybe get to take your picture with it once as the scientist. But they're not going to let me touch anything that's, going to Mars, or, I can help on it, help design it and such. But yeah, it kind of felt like it was a chance to be part of some big thing. Yeah, and
Yeah.
I'm working a lot too on the human return to the moon, and
Oh, cool.
yeah, so I'm
Wow.
on maybe six different of these new upcoming moon missions as well.
Oh my God, that's so cool.
Yeah.
Uh, it's so cool.
Yeah, one of the things
Sorry.
I do is temperature models of ice at the poles of the moon. And so, for instance, the Viper rover, which is it's a rover that's going to land at the south pole of the moon, and it's going to drive around, and it has a drill to drill for ice, and
Oh,
it's basically following my maps of like,
Oh
oh,
my
that's
gosh.
this is a
so
crater that's
cool.
cold enough that ice could be within the upper meter here, and so why don't you drill in that one first? And then so it's kind of fun when there's like $1 billion mission to prove you wrong.
God, that's so cool. I think, oh shoot, I had something I was going to ask you.
I was going to ask something. Can I?
Okay, great. Yeah, please.
So could you take us through kind of your career a little bit? So you mentioned that you did your grad work in particle physics, or no? Was that, and then where are you currently?
Yeah, so I mean, I think my career is kind of a good lesson for perseverance or whatever for a student. So I did undergrad. I started as a film major in at Ithaca College in New York, and started taking physics classes because I thought, oh, maybe I wanted to do special effects or something like that.
Oh,
And then basically, as I got more into the physics and astronomy part, I Ithaca College, was a great film program. The physics program was like a 3-year program, and then your senior year, you basically took classes at Cornell in physics.
Oh, okay. Got it. Yeah.
And so I just decided it was, for me personally, my interest, it was better to transfer to Cornell. So I finished my degree at Cornell and really got involved with the old Mars rovers, Spirit and Opportunity there. But then during the summers, I lived about 15 minutes from Fermilab in outside of
Oh,
Chicago.
yeah. Because you're from Illinois. Is that
Yeah.
right?
Yeah.
Because so are we.
I'm from, you've never heard of Wayne, Illinois? The
I
metropolis of
have
Wayne,
not.
Illinois?
Where is that? Is that a suburb? No.
Yeah. It's basically, people have heard of Elgin and St.
Oh,
Charles.
we're
Yeah.
from
So
McHenry.
yeah. So it's this like little town of 2,000 people that's kind of right in between all those, surrounded by
No
all.
Oh,
kidding.
wow.
Yeah. Yeah. We're from like, I don't know, 45 minutes north of there or something.
Yeah.
So, yeah. Oh,
Yeah, so I
funny.
went to high school in Elgin and at Elgin High, yeah. And but then so then after undergrad, I was like, okay, do I want to do particle physics or do I want to do, Mars stuff or do I want to do film stuff? Do I want to try to work on science documentaries or something? And so I basically applied to a bunch of grad schools and didn't get in anywhere.
That makes me feel so much better because I
Yeah.
didn't get it.
I was going to say
think
familiar. Yeah.
yeah. Yeah.
And I think people are not used to hearing this from their professors, because like, oh, like it was just easy for them, Like I had one
Yeah.
professor at Cornell that like took the physics GRE every year just to prove that he could still beat all the students. It's
That
just
seems like a great use of your time, doesn't it?
Yeah.
Like,
but basically it was it was humbling to not, get chosen. So I said, okay, I'll try out different careers. So I went and actually worked at University of Zurich on a project for CERN for a year.
oh, cool.
I designed part of the cooling system for LHCb. And that's when I
Nice.
first got like working on temperature stuff because when I was doing this
Okay.
thermal modeling for how you would cool off a detector when it's getting irradiated by particles and such. And then but I was a little jealous of my friends that were in California working on the Mars rovers then. And so I basically got set up to start doing lab work at Caltech associated with the Mars rovers and with the upcoming Phoenix mission that was going to Mars. And that was going to do temperature measurements of the ground on Mars and measure ice content of the soils. And so I went over and I was working at a lab at Caltech for that. And then applied to grad schools again and didn't get in again.
Oh, now I just feel angry. Like, what is wrong with them? How dare they? How dare they?
Yeah, and then then I kept doing the lab work and got involved with that and kind of through that met the person who would be my advisor at UCLA. We met for coffee one day and he's like, "Oh, well, you sound like you want to do grad school, so let's start you next week."
Oh my God.
Kind of started grad school finally through the door after 3 years of not getting in. And he had my advisor had been head of the 1999 Mars mission, the one that unfortunately crashed. And
Oh.
he was kind of in the middle of a career rebirth himself working on the moon. And it was the first mission going back to the moon, the Lunar Reconnaissance Orbiter, or not the first one going back, but one of the first. And so, so then my career kind of, my PhD was all about the moon and ice on the moon and temperatures on the moon and the history of the moon's orbit and all that kind of stuff.
And I gotta say, I don't think I've paid enough attention to the moon lately because I
Oh,
didn't
fun.
realize. I mean, like, I didn't know that there was ice on it. When did we find that out? There's a lot that I'm like, oh shit, I should have known that. Have we known that forever and I just forgot? There's ice up there?
I mean, people theorized it back in the 70s.
Okay.
But because essentially the moon has, essentially no tilt, like a 1.5 degree tilt. And so a crater near the north or south pole of the moon is deep enough that it will always remain shadowed. And so surfaces on the moon that never get any sunlight are actually colder than the surface of Pluto, because Pluto is pretty tilted.
Ah,
All
yeah.
sides of Pluto get light at some point, but there are
Wow.
places on the moon that just never get any sunlight at all. So they can be, and with the reconnaissance orbiter instruments, we've measured temperatures down to about 20 Kelvin.
Oh, wow.
Nice. Wow.
And
Cool.
so it can be really cold on the moon. And so theoretically, any comet or wet asteroid that ever hit the moon, some of those water molecules are going to stick.
Ah, yeah, okay. That makes sense.
Yeah. And so basically, we're trying to figure out how much is there. And back in the 90s, they shot radar at the poles of Mercury, and found that there were bright reflections from the poles that seemed to be telling us that the cold traps on the poles of Mercury are full of water ice.
Hmm.
Wow.
And then that got people excited about the moon. We've sent a couple missions now with different instruments. And we found maybe, oh, it looks like there's half a weight percent or something of ice here. And maybe that's like blotchy. And there's really like, you know, 2 meter sections of pure ice surrounded by
Ooh.
lots of dry dirt or whatever. And we're trying to figure that out. Is there ice in enough concentration that it would really be like useful for astronauts to have a martini or whatever you want to do with it?
That is exactly what I was thinking was like, is there enough ice that to celebrate its discovery, you could use it for cocktails?
Yeah, yeah.
Like that would be like, I feel like that's what I would be most interested in would be like, if there is, then the project of like naming the cocktail and like having like a special one and like
And so that's basically
that's where my
what a
interests
lot of
lie.
these new Mars or new lunar missions are about is trying to figure out, okay, we know where the ice should be. Can we measure how much is actually there? And is there enough there that it would actually be cheaper to, scrape off the soil, boil the water out of it, and would rather than bring it to the moon from Earth? Because, you know, it's both exciting in that scientifically, this is kind of a record of all the objects that have ever delivered water to the moon, and
Yeah.
therefore that have also delivered water to the Earth, right? That's one of the big myths
Yeah.
about the inner solar system is when the whole solar system is forming, it's this hot, gas and dust that mixed, and so heat actually travels through that gas, right? So the inner solar system is thousands of degrees, right?
Hmm.
And so water boils off and goes to the outer solar system essentially. And so the inner solar
Yeah.
system should be pretty dry. And yet we have water on Earth. We seem to have water on the poles of Mercury. There's
Huh.
water in Venus's atmosphere. There's ice on Mars. And so um, one of the questions is how did it get here and did it come later? And so right now, I think the most popular idea is that some event early in the outer solar system caused a lot of icy objects, comets or Kuiper belt objects or whatever you might want to call them, to come into the inner solar system. And then also some of the asteroid belt was icy and that also migrated around. And those objects all collided with the Earth and the moon, and brought the water that we have on Earth today. Um, but a record of that is lost on the Earth, but it's kind of still sitting there on the moon
God,
potentially.
that's so cool. That is
Yeah.
Yeah.
awesome. Yeah. God, I
Yeah,
love
and then
that.
there's the exploration aspect of it of the space shuttle, those engines were hydrogen and oxygen mixing together, right? And you made water essentially and a lot of energy. And that's how the space shuttle launched. And so um, it could be if you have lots of water on the moon that the moon essentially becomes a fueling station. And it's because the moon's gravity is so much less, to go on and explore the universe,
Yeah.
having a way station at the moon would be a lot easier in some sense. I mean, I don't know. It's kind of, it's borderline between sci-fi and would it be practical? And it kind of
Yeah.
depends how concentrated the ice is. And so that's kind of what we're trying to figure out now.
God, that's cool.
How cold is Mars? Like, what is there's ice there. Is it, I mean, what's it
We
like?
wouldn't, would we
Yeah.
need a jacket? Would we need a jacket? Would we?
Yeah, I mean the warmest Mars will ever get at the equator is like 60 degrees Fahrenheit, something
Okay,
like that.
that sounds beautiful.
Yeah,
That I
yeah.
just was telling Helen's
Yeah.
son, William and I were talking about it, Helen, because we thought it was too warm on Sunday, even though
Yeah.
everybody was talking about a beautiful. We were like, no, we want it to be like 60. So that would be
Yeah.
like Martian summer. Okay.
Yeah, yeah. But the air is so thin that you'd probably get cold anyway. The air is about
Hmm.
Mm.
100 times thinner than our air, and so
Wow.
just doesn't hold the heat very well. And
Okay.
so the problem is that same night you'd get to minus 200 degrees or something.
Oh.
Um,
Okay.
yeah, but and then the coldest you can get on Mars is actually controlled by the atmosphere. Is about I think it's 145 Kelvin is when
Oh my God.
CO2 will condense as a solid. And so
Okay.
Whoa.
basically, near the poles of Mars, it can get that cold, and then the atmosphere will actually start condensing out. You basically are making CO2
Whoa.
snow in the winter and the poles of Mars. Yeah, and so that's kind of the cold range. So
Wow.
Man.
145 Kelvin to what is 60 degrees is, yeah, 273 is zero, so something like 300.
So wear layers.
Yeah,
So
wear layers. It's cold.
yeah. Yeah.
Yeah, I mean, Mars isn't quite as bad as the moon. You're not going to get quite as cold as at night as you would on the moon because you still have some atmosphere. It turns out like it really matters how dusty the atmosphere is as
Hmm.
to how much heat it's going to radiate down.
Hmm.
Um, how much heat the atmosphere holds depends on whether there's a dust storm going on or not.
Oh.
And so yeah, but Mars is pretty damn cold at night, I think.
Man.
What is in the soil? You mentioned that it's not like the same shape, but it's a similar
Yeah,
composition, or what is it?
I mean, most rock on, Mars is volcanic rock, basalt.
Okay. Okay.
So this remains in that have
Is
already.
this why you're going to Hawaii?
Oh
Does this have anything
yeah.
to
Well, they do actually do a lot of like there's a whole Mars simulation base on Mauna Kea where they drive rovers around and sometimes people live in a fake Mars base and pretend,
my
kind
God.
of test out the things you would for a Mars mission, but then you also test your new instruments and new rovers, so it's only half playing. Some of it is for real science, but yeah, it's always hard to have something and say like, oh, this is a good analog or not. Yeah, but basically, um, because the astronauts in the 1960s and stuff trained there, and they had originally, I mean, the Hawaii is actually a good launch facility because
Oh.
if you shoot a rocket pretty much in any direction, you're going to hit ocean, right? Whereas we launch
Sure.
all rockets that we're trying to launch east-west, we launch them from Florida, and all things that are going north-south, we launch from Vandenberg in California because there's ocean in the way. And so
I
the
never thought
Navy
about that.
especially had developed Hawaii as a potential launch site. And so it just since the 1960s has had a tradition of planetary research in the department there. So it's a
Cool.
cool place to land.
Wow. Now there's ice there. Is there any sign of microbes or
And I
any
should
sort
also
of
add, we asked our listeners if they had any questions, and we mostly just got really absurd questions from our cousin Rob.
Okay.
And so he wanted to know, is there a possibility of life on Mars? And if so, how would it taste in a crepe? Was the second part of that.
So basically, we first went to Mars with the thought that there might, so I think it was Immanuel Kant no, who was it?
Oh,
Some like really like that era, 1600s. Um, Basically, they when they first were observing Mars, they saw that it changed color a little bit seasonally. And so there was originally this thought that there was basically seasonal cycles on Mars, and it was like getting covered with plants and not, and so that, and then when Percival Lowell did all his observations of Mars around the turn of the century, he uh, he got really depressed at first in a way because you could see that Mars wasn't green. It was all brown. And there were some kind of cycles, but they appeared to maybe be dust cycles. So Mars was already showing that it was a desert planet. But he saw these kind of linear features that he thought, oh, maybe they're canals. And the
Right, the
Martians on
canals
the
on
dry
Mars.
planet are building canals to irrigate the dry parts of the planet. And then that was kind of the image we had of life on Mars is, yeah, there's Martians there and they're living in this desert and they, need these canals to carry water to and fro and all that. And then we landed on Mars in the 1970s with Viking and basically like, didn't see any animals walking around, any footprints or anything like this. And they had then it was kind of getting to okay, there's microbes. And they had an experiment on the Viking lander that basically squirted like a chicken soup, essentially like a protein-rich water into some Mars soil and started giving off gas. And people got really excited that this might mean that there was life. And when you sprayed water on it, the soil comes to life, and it's yay, we found life on Mars. And that's what I think even the newspapers said for a while. And then they watched the experiment over time, and the gas stopped. And then they sprayed more water, and it didn't come back. And they're like, "Shit, we killed life on Mars." But what it turned out to be, and we've found this with subsequent missions, we've found perchlorate salts, which are do something similar to Alka-Seltzer tablets. You see
Oh, okay.
basically if you have these materials, or it's like hydrogen peroxide, right? It will fizz when it gets to
Like
water.
Mentos and Coke or whatever.
Yeah,
Yeah.
yeah. And so, but eventually that chemical reaction runs out. And so far, any sign of life on Mars has probably been, cast away as being, um, but it's still a compelling part of the search. And now it's kind of like, well, there could be life deep underground, right? We have a lot of ice in the Mars soil and at different locations. Sometimes we're finding signs of ice, near the equator of Mars even and so if you go deep enough, you'll get warm enough that ice might melt and you might have like underground wet places. And we have seen potentially seasonal outbursts of methane from Mars.
Wow.
Oh,
And so like some people are like, oh, maybe this is, methanogenic
those
bacteria that are,
cows. No.
yeah.
Martian cows.
Cows,
Yeah,
yeah.
yeah.
So yeah. So maybe, it seems like more and more desperate version of what we call life, but it still could be some form of life that, and that's the crazy thing about Mars. So like with the Perseverance rover, we're now driving up this delta on Mars, which is a river delta, but it's a river
Wow.
delta from like 3.6 billion years ago, right? And so
Wow.
Mars used to have lakes and rivers. We could drive and see that there were. Um,
Man.
and something happened on early Mars where it looks like the magnetic field of Mars shut off.
Oh,
Oh.
And so
Oh, that's
Mars was
scary.
probably equally or potentially even more habitable on Earth for its first billion years or so. That the Earth was actually still kind of hot and molten a little bit longer than Mars was. So Mars kind of cooled off and became somewhat habitable and had lakes and oceans potentially. Um,
Man.
and then, or it might be that it had ice, and these are just like occasionally like the bottom of the glacier will melt, kind of like what we're doing in Greenland today, right? And
Oh,
you'll get
God. Yeah.
outburst of water, and that might be what fills the lake. But these deltas are showing us that there was at least recurring water in these places, hitting another body of water that was there at the time. And so um, it seems to be implying that there was a lot of water for that first billion years or so. But then when Mars's magnetic field shut off, the magnetic field protects a planet from solar wind particles, from electrons and protons and stuff that are getting spit out by the sun all the time. and these will hit atoms in the atmosphere, break them apart. And then if it breaks apart into light enough atoms and you're a small planet like Mars, you can't hold on to those molecules anymore and they fly off. And basically, Mars's atmosphere today is made of those things that can freeze out on Mars, under the temperature. So it's made of the CO2 that we said, freezes
Right.
winter. So you can imagine Mars in an ice age might freeze out all the CO2. And it freezes out most of the water vapor in the atmosphere is frozen in solid ice at the poles. I mean, there are, kilometer thick blocks of ice at both poles of Mars. So
Wow.
there's lots of water there. It's just frozen. And occasionally we find some evidence of, oh, it's occasionally liquid, or maybe this feature is caused by liquid coming out seasonally. But yeah, but it's for the past 3 billion years, roughly, Mars is not, on the surface of Mars at least, has not been a very habitable place for Mars or for life.
Hmm.
But yeah, maybe deep underground there's some bacteria brewing. How that would taste on a crepe, I don't know. Scrape up some of your, probably like Vegemite. I don't know, your favorite
Yeah.
in bacteria. Or maybe I don't know, go to Old Faithful and scoop out some of that,
Yeah.
spread it on some bread
Yeah.
and see how that tastes.
Now, I find the idea of the magnetic poles stopping very alarming. How does that happen? And is it going to happen to us?
I mean, so there are two ways, and we're kind of on the fence about what happened on Mars. So basically, we think a magnetic field comes from the fact that you have an iron core. So
Mhm.
so you have a planet, it's got all the different elements in it. Iron and nickel and some of these heavier elements will sink to the core. And they're under intense pressure and heat. And so sometimes they'll be liquid. And then in Earth, we're a big enough planet that our core is so compressed in the center that we have a solid core. And so now it's like a blender, basically, right? We have this solid core that's rotating at a little bit different speed than the liquid core around it. And so that causes the outer core to like swirl around. And when you have something that can conduct electricity and you spiral it, you make a magnetic field, right?
Okay.
Like if you
We were
were
just talking
winding
about
the
this on
wire
that
around the
couple
nail.
episode again.
Yeah. Yeah. And
Yeah.
so this is what we call a dynamo. Essentially, a spinning body with a liquid core and a solid inner core seems to generally generate a magnetic field. We have evidence that the moon used to have a magnetic field. We have
Oh,
evidence that
wow.
Mars used to have a magnetic field, but somehow they shut off. And so the easy answer is, well, Mars and the moon are smaller, so they cooled off faster. A cupcake will
Hmm.
cool off faster than a full-size cake. So,
Yes.
yeah, so that's probably what happened. But one of the things we're studying still with the data from the InSight mission, which had a seismometer to measure crustal thickness and all that, is that it may be that the crust of Mars is kind of so thick and so good at trapping in heat that is warmer inside, and actually the whole interior of Mars, its core is all molten, so you don't really have.
Ah.
And so it's a matter of like how good you are at getting heat out. If you're really good at getting heat out, your magnetic field's going to turn off real quick. If you're not good at getting heat out at all, then it's going to also turn off, right? Because you get too warm. So you need kind of this in-between balance. And the Earth has had that for a long time, and probably will. I mean, we lose heat through volcanoes and stuff, but it's a slow process compared to how much heat is down there, I guess. I don't think we're
Wow.
gonna. What might happen on the Earth, and what is fun, we can look at the if you look at the bottom of the Atlantic, they actually discovered this with submarines during World War II, is that the magnetic field of the Earth changes direction every, 10 million years or 1 million years, something. It's kind of irregular.
What?
Yeah.
So what we don't know is like basically your compass, instead of pointing to the North Pole, would point to the South Pole. That's kind of a novelty
Whoa.
there, right? But the big question is like, well, does the magnetic field turn off in between?
Oh, right.
Oh, yeah.
And so, I mean, it's like having, you know, 5 years with a weak magnetic field or no magnetic field might not be so bad, but if it is like a 10,000 year cycle, then we start to like
Yeah.
thin our atmosphere out, and that might have effects on climate and stuff like that. And we just don't really know, but there aren't, some people have tried to tie mass extinctions in the past with magnetic field cycles, but so far I don't think there's been a convincing like nail in the coffin saying like, oh, like here's this mass extinction and here's the magnetic field shutting off. So yeah, so it seems that life has survived it before, but
Wow.
usually that life wasn't like communicating by bouncing waves off the ionosphere and all that. Like
Right.
so, so AM radio might take a hit. I don't know. We'll see.
And how often did you say we think this happens? Where it switches directions?
Roughly on a 1 million year time scale, between a million and
Wow.
yeah, because the
Yeah, see, that doesn't seem
explorer is
like that
about 200
long.
million years old, and I don't know how many stripes back and forth it is, but yeah, it's
Wow.
irregular. Yeah.
Wow. Oh, that's so cool. Huh.
Nature has some randomness. But yeah, people get really concerned. Like the magnetic North Pole on Earth has moved quite a bit in the last 150 years or so that people have really been monitoring it. And it's like, okay, is it how
It's
much is it
yeah.
moving?
Is it getting ready to go?
Yeah, yeah.
God, that's wild. And so I don't want to use it and go over on your time too much, but I just wanted to ask because we are, an X-Files podcast primarily. I wanted to also ask, did you slash do you were you a fan of the X-Files? Did you ever watch any? Do you have any thoughts about it generally? And then I have a Mars specific question.
Sure. I mean, I thought the X-Files was really fun. And it was before I was like a scientist or whatever, and had to like like say like, oh wait, maybe I question some of these these strange things going on. But I mean, I think it's it's that kind of thing, and that kind of entertainment that gets people excited about it. Like I got into space because I watched Star Wars as a kid, and like now I'm like, sure, I could complain that like, yeah, when you blow up that TIE fighter, it's not gonna make a noise or whatever, but like it doesn't matter. It was the cool thing that
Yeah.
got me first interested in space, right? And so if the X-Files and that, inspired some people to like go into science or take on some, special interests, then I think that that is, totally, a neat,
Yeah.
that's what science entertainment is supposed to be about, is about both, both pushing what we know, and, there are tons of things we don't know. And, X-Files was a good, did a good job at finding the, poking at these holes of things that we don't really know, and it was believable enough that you could like follow it, yeah.
Yeah. Yeah, it's been really interesting because, we watched it a bunch when we were younger before we were scientists. And so rewatching it, like, yeah, there are certain episodes where we're like, yeah, that works. And others where it just is taking us out entirely. Um, but mostly I feel like it's still really awesome to watch. But there's one episode that is specific to Mars. It's not an especially famous episode because it's bad. It's not well. It's season one. It's an episode called Space, and it basically there's like a scientist or an astronaut doing like a spacewalk for some reason, and like the face on Mars kind of zooms off and possesses him, and he
Oh,
like kills people, or like he like sabotages a mission and stuff, because he's been, as far as we can tell, I don't know, he's doing the spacewalk, so he's closer to Mars, and so the face on Mars gets him, I guess. It wasn't very good, but
I mean,
what
yeah,
I
it's the
wanted to
kind of thing
ask,
like
like,
if like science can't really test life after death, right? And so if life on Mars did live, 3 billion years ago and died out, and there was some remnant of it, then yeah, maybe those bacteria could haunt you. I don't know. But
I
yeah,
like I like the idea of
the
ghost
face on
bacteria.
Mars is a funny one in that it basically, like, we have great images of that hill now, and it looks
Yeah.
nothing like a face when you see it all illuminated. And the really convincing thing about the face on Mars was that it had a nostril where the nose would be, and that was just a missing bit from that image.
Oh God.
And so, but yeah, you can go and find the modern versions of pictures. It looks like it's probably a wind or water carved feature. Looks nothing like a face when you see it fully illuminated. It was just like a trick of the lighting and
Yeah.
lost data points. But it was a cool thing that got a lot of people excited about Mars, and maybe we didn't have that type of life on Mars, but maybe it's you know keeps the bills coming or whatever keeps the bills.
So yeah, I was curious, like, because I feel like every field has like the questions that people who aren't in that field really want to ask. Like, my husband's a historian, and so he always gets people that want to like monologue about weapons used in old wars to him,
Oh
and
yeah.
he's like, "That is not what I do," you know. And so I was curious, do people ever bring up the face on Mars to you, or is that kind of distant enough now that like randos aren't talking to you about the face?
Yeah, I haven't heard that for a while, that one. Like, occasionally you'll have people that are really like, oh, there was this object that was seen by the Mars rover, and doesn't it look like a hatch to underground base or whatever? Like,
Ah.
so looks a lot like a rock. Like, and it is fun, the interesting features, and you'll name them after whatever, like the people driving the Mars rover, the rover team names the objects they see, and it's kind of evolved over time that they're like, okay, we need to do more serious names, because people might take things too far.
Oh
and
no.
and it's gotten very serious. Like, you have to get, basically, approval through the Astronomical Union to name a feature on Mars. And
Wow.
like the um the area on Mars where Perseverance landed, for instance, a lot of the features around there were traditionally named after Navajo
Oh,
names. And so that kind of province on Mars has like a Navajo tradition. And so the Mars rover team actually went to the, Navajo Nation and, kind of worked out a naming scheme that would not be offensive to the Navajo people and would like, carry on their tradition of naming things and how to name things, and so they got certain names approved for the craters or hills or different features they found that, and so there's kind of
wow.
a list.
That's
Yeah.
cool.
So people are very serious about naming things on Mars because, yeah, if you just like casually name it, like, oh, that one looks like the hatch, and then people are like, "Forget about even the NASA scientists named it the hatch." So, but, but yeah.
Um, do you find, because I feel like Helen and I would both think this, I know I would. Do you ever personify the rovers like to an extent where you feel like worried about them or like sad or happy for them or
Oh
like,
yeah. I was so broken up when Opportunity finally passed away or whatever you want,
Oh.
like, because it was 14 years it was driving around the surface of Mars, and I had grown up with it essentially my whole science career, at least since undergrad. And it was, yeah, it's, you really do, you know grow to love these these
yeah,
creatures that you built. And yeah, and there's a whole, you know society around them. And yeah, it's more than just the team. It's that you really love this creature that brought you all together. And it does these amazing things that you could never do. And so yeah, so
yeah,
it's really another another creature
yeah,
you become very fond of.
yeah.
Is there
Oh,
anything there
yeah.
right now?
On Mars.
Yeah. Hmm.
So the two so there's two nearly identical rovers called one's Curiosity, and that's driving up a hill in a big crater called Gale Crater, and it's driving up this hill that seems to have layers of an ancient lake bed sediment and ash deposits. And then there's the Mars 2020 or Perseverance rover that is driving up this river delta in Jezero Crater, nearly on the other side of the planet.
Wow.
Um, and I believe maybe the Chinese rover is still active, and then there's a whole bunch of orbiters actually. We use them as relay satellites, so I think maybe there's 5 different ones that are orbiting still in operation right now that from different nations that act as relay satellites to the rovers and such, and have their own great suites of science instruments.
Wow. And so was it the Mars 2020, the one that has the thing that was supposed to dig and didn't dig as deep as it was supposed to, or is that the other
Oh no,
one?
that's the InSight mission, and that
That's
officially
insane.
did maybe about a year ago.
Okay, I knew one had ended recently, but I have not kept track at all. So I
Yeah, and
wasn't.
it's kind of a little bit by luck. So that one was solar, it had solar power, whereas Perseverance and Curiosity are both have a radioactive power. So they basically have a stick of
Wow.
plutonium in surrounded by a jacket of things that converts heat into electricity. So that's what
Wow.
the big fin thing sticking off their butts of the rover is. But is so they'll last for probably 15 to 20 years each if maybe a wheel will break or something like that, and they'll become immobile, but the power should last quite a long time. InSight, basically, it was an area where uh, dust was slowly settling, and after enough, I think it was 4 years total or so, the dust just got thick enough on the solar panels that it kind of blocked off its electricity. Whereas the Spirit and Opportunity, those Mars rovers, luckily, we're in an area where windstorms came by often enough that blew off the dust. And maybe it was because they were moving at all different angles and such that they got lucky to get hit by a little dust devil more often. But they had
Wow.
these cleaning events that made it, those they thought those rovers were going to last 3 months initially.
Oh,
And
wow.
they ended up lasting, Opportunity lasted 14 years. So
Right.
Wow. That's
Yeah, there
incredible.
was another X-Files episode sort of inspired by that, but it's at a volcano. It's called Firewalker, where they have a rover-esque guy thing that's meant to go inside a volcano where it's really hot. Um, and so I was reading about how this was, I think, 94. And so one of the things that I remember from that episode is, we just watched it a couple months ago, is them talking about, oh, well, we have to go on the surface of a volcano and map out everywhere first where it's going to drive. And I felt like, doesn't that defeat the purpose? And that's definitely not what we're doing with Mars. And it turned out then I think there ends up with, that was the one with the big, like the things that look like baseball bat asparagus size and that like
Oh,
burst
yeah.
through and like kind of like alien. Yeah. They like found something deep and like a fungus that was buried deep in this volcano that then started, infecting scientists, and then they'd get mean, and then they'd have like a big giant asparagus burst out of their chest. Um,
But they do
like
that.
you do.
They map they map it out in way detail. We have all the planned, different ways the rover might drive, and the whole team gets
Wow.
together every week and debates like, okay, which path are we going to go on from here, and where do we want to get to by which date, and then like, oh, we lost communication for 3 days, and now we can't get there in that time, so we're going to take this shortcut instead. And yeah, so all that is planned out in detail from orbital
Wow.
images of the landing site, and that was part of one of the cool things about the helicopter that was with Perseverance is that it basically allowed it was hopping along with the rover and making high resolution maps along the way as kind of a test for like, could we do this even better? That we
I
can really
see.
map it out. And it wasn't really, it was more just an experiment to do, but that ended up being a kind of operational role as it could scout out ahead where the likely path was and get some really high resolution images ahead of time so that we'd know like where every rock was along the way. Yeah, so you do map everything out in detail, but you can't map composition. You can't drill and collect the
Yeah.
sample, this is from space. So you have to do that all from the rover. But
Yeah.
yeah, it
And
really is thinking all these different dimensions of like, what's this look like in a map view versus driving around and all that. Yeah.
Yeah.
and again, we don't want to take up too much of your time, but I did want to ask, do you still this is super cool. Do you still realize how cool it is that you work with space,
No,
or do you kind of become like immune to it after a while and just kind of it's day to day?
no, I think in every field you feel like the stupidest one in a room full of really smart people. Like I think everyone everyone goes around feeling this way, like I just am like, oh, well, everyone must know more than I do about Mars in this room that I'm, in this meeting I'm having, and I feel like I'm an imposter here. I think that is kind of a way that a lot of scientists are.
Yeah.
Wow.
It takes a lot to really have this feeling that you yourself are the expert. And it's all such a team effort. I mean, that's kind of what's fun about these planetary missions is they're big teams of people, and there's never too much responsibility on one person to get everything right. Um, and but you never feel like you are the one that knows everything about it. So yeah. So
It's awesome. So yeah, you're still just like, this is really cool. I'm doing this. It's not just like another day, another
I
rover
mean, I think you
thing.
can
Yeah,
get
like yeah.
really bored of like, oh, another, I don't want to get up for this telecon today. Like, oh, the rover hasn't
Yeah.
moved in 3 days, so this, like issue with the rover wheel, or oh, this data doesn't look good. Like I don't know. It just, yeah, you can get bored of it too. Like it can. I don't know. You need to step back on anything to not lose your its novelty. So.
Yeah.
Well,
Yeah.
this was awesome. Thank you so much. We so appreciate you talking to us.
Yeah, absolutely. It was really fun to have you. If there's anything else you want to share or websites you want to point people to or anything you want to like mention last before we go, and we can also share it on our page. But yeah, anything else you want to add, feel free. Like things
Okay.
people should look at. I don't know. I think I'm
Yeah, I
like
mean, I think
feeling like,
what's really neat about all these missions is, especially the Mars missions, all the images are put up pretty much instantly, like within
oh,
so you can go to the Perseverance website and see all the new images that were taken in the last few days, and really like
wow.
stay up to date
Wow.
with what's going on Mars, and basically all the data from every NASA mission has to be publicly released in some form within 6 months, whether you understand what the data might mean or not. It's not all pictures and images, but yeah, I mean, I think and bug scientists about this every scientist wants people to care about what they're doing, and I think people think like, oh, I can't bother this person in my university. But if you're a high school student and want to like learn about something, you go and they'll be happy. Scientists are happy to talk about their work. So yeah, and this is fun work with lots of images and stuff. So it's a cool thing to show off.
And what was the YouTube show that you were doing with the guy from
Oh,
PhD Comics?
yeah, so PhD Comics is basically the Dilbert of the planetary or of the grad school world. And so Jorge Cham started doing it when he was a grad student at Stanford, and is now doing it full time. Uh, and he a few years back we did a web series with him called PhD TV. So on YouTube,
PhD
there's a
TV.
whole channel of a bunch of different things we worked on. Some are animations of his, some were we did a travel show where we went around to different uh, grad schools around the world and like
Huh?
interviewed people about their research. So I got to go to uh, London and Norway and Hawaii and Curacao and Saudi Arabia. And so we went around and interviewed students about their research work. Yeah, it was a lot of fun.
Oh, that's awesome.
Jorge, for those that have kids, he makes Eleanor Wonders Why.
Oh, no kidding.
Yeah,
That's great.
So
It's a great show.
so that was recently I got to be a science advisor for an episode about rocks.
Really? Oh, that's awesome.
I can't tell you anymore.
I'll have to go rewatch that one.
So yeah. Well, thank you for all your questions and thanks for inviting me.
Yeah. Yeah.
Thank
Thank you
you.
so much for coming. Yeah, this was great. And good luck with the move to Hawaii. And
Thank you.
and I'm hoping I'll let you know if I get my hands on any of the simulated dirt and what type of dirt it is.
Okay,
So-
if not, I guess I can go over to Mauna Kea and scoop up some more.